Today I start one important topics related to non-linear space. Okay, one important topics in non-linear space, which today we discuss about quotient space. We know about that. This one is important space. We just talk about some linear vector spaces, and we are now defined some quotient space. Okay, this one of the that means important space to handle, that means mathematics. So we talk about now which one we talk about L be a some linear space. Okay, and then y be a subspace of X, y be a subspace of X. Okay, then what happened? Then for xy belongs to X, for xy belongs to X, define some X related to Y by implies Y, X difference Y belongs to this Y, this capital Y. Okay, then what happened? Then this delta be an equivalence relation, be an equivalence relation. Okay, so how this one is happen? First we prove this one. Okay, this one is too easy, I think. If we write X related to X, then X difference X, 0 belongs to Y, and if X related to Y, then this one belongs to Y, and obviously Y related to X because Y minus X belongs to Y. Okay, some subspace, so we multiplied some scalars minus 1, and again we also write here X related to Y. That means we write in this way, X related to Y means X difference X equal to 0 belongs to Y. This one happened. X related to Y means this implies that X difference Y belongs to Y. So this implies that Y difference X belongs to Y, because Y be a subspace, we write here Y subspace. Okay, and here this implies that Y related to X. Next we talk about in this way X related to Y and Y related to X, Z. Okay, if X, Y, Z belongs to this X or Y, this implies that X difference Y belongs to Y and Y difference Z belongs to Y. So what happened here? Here we write X difference Z equal to X difference Y plus Y difference Z. Okay, this 2R belongs to Y, so this one obviously belongs to Y since Y be a subspace. So what happened? So happened here X related to Z. So we talk about that. This one is done. That means this one be an equivalence relation. So we erase that portion and going to further discussion of that. Okay, so equivalence relation, how this that means this relation how become a equivalence relation. We also gives supporting that means result. Okay, so how we further proceed? We also proceed now how we define equivalence class. That means X belongs to X, then equivalence class we define. Okay, because this one form a equivalence relation, so equivalence class is needed here. We write here equivalence class of X B. What we write in this way, this one equal to X plus Y such that Y belongs to this capital Y, equal to X plus capital Y. I understand, not a problem at all. So what we write in this way, how this one behave. Okay, how this one behave, just in we write in box X, or that means this one is parenthesis, I think. Obviously third bracket, in third bracket this one is X. Okay, then this one is okay, one type of braces I think. And this one X plus Y belongs to Y, so X plus capital Y, this one is set Y. Okay, so here we write in this way, and we'll write here x difference y denote the set of all cosets. We write this box x. Okay, for x belongs to y. Okay, then what happened? Then we write in this way. We erase our portion and going to further discussion of that. Okay, further discussion of that. What we write here for x y belongs to x, for x y belongs to x. Okay, and alpha belongs to k, and alpha belongs to k. What we write? We define here, define box of x plus y equal to what? Equal to box x plus box y. Okay, and here alpha multiplied by box x equal to box of alpha x. Okay, then what happened? Thus x, this quotient y is a vector space over k, is a vector space over k. Okay, I think not a problem at all, or understand about those property. Okay, so we're going to further discussion of something. Okay, how this quotient space become a normed space we also discuss about in later, but now we stop here.